First, bonjour. Right, video number 4 is all about beaches, all right, and beach features. And if you've been taking note when you've been paddling at the seaside as a nipper, then you'll probably recognise some of these beach features. So today is a lesson that at the end of it, you can bore your parents and your mates on holiday when you're sunbathing on the beach. You can start explaining what different landforms and features are and how they're formed. All right, so excitement. Right, today then, key area 2. Key area 1 took us what, roughly 5 weeks, which is pretty good going. So start of key area 2 is this section just here, where we're going to look at different wave types and how those different wave types cause different beach features, different sediment profiles, etc. Alright, here are your keywords that you're going to get familiar with today. Okie dokie, let's do it. Right, if you've studied GCSE geography, then you're probably familiar with these terms, and you've heard me mention them in class already this year. There's 2 main types of waves, alright. Constructive waves, which, like in the photograph, have a really strong swash or run up the beach. They tend to be really low height as well. So as you can see in this example, yep, not the type of wave that you'd surf. Alright, it's the type of wave that we find in bays, like in this photograph. Low energy, low height, and they kind of surge up the beach. Alright, they've got a really strong swash and a really weak backwash. Just another example just here. Yeah, surging waves, strong swash, weak backwash. On the other hand, you get more higher energy, destructive waves, which have got a much larger or longer wave height. So you can see these are crashing onto the beach. So yeah, these have got a weak swash and a strong backwash. And whenever we look at any beach features, chances are, well, they're going to be caused by one of these 2 wave types. All right. This is a graphic of the littoral zone and the subsections in the littoral zone. Very first lesson with me this year. You've got a graphic that's similar to this in your folders. Very first page in key area 1. And if we just have a look at the different zones, we've got the backshore, which is at the back of the beach. Behind the backshore, we've got your cliffs or dunes. Foreshore and nearshore tend to be where the waves break, and actually where we get the swash and the backwash in these 2 zones. And then offshore is shallow waters, beyond where waves break. All right, and if we just have a look at the different types of sediment just here, we can see we've got pebbles, which we tend to find in the backshore, shingle, which is slightly smaller than pebbles, and it gets gradually smaller and smaller. All right, and that's because, if we use a bit of logic, you need more energy from the sea to get larger material further up the beach. Alright, so if we've got an environment that's really settled and calm, and it's never going to receive a high energy shock from a storm, then the chances are you're not going to see pebbles this high up the beach. Alright, because the larger, the heavier, and it needs more energy for the sea to basically deposit those larger pebbles further up the beach. Yeah, so beach profiles have some element of kind of sorting by size and by shape. All right, in the backshore we're going to find larger material, because we've needed a lot of energy to get it there. But gradually, as you move towards the offshore, the size of the particles and sediment gets smaller. Okay, folks, I mean, you can make notes on line paper if you like, but there is a space in your booklet on page 5 to start filling in page 5. All right. So beach morphology then, what does it mean? Well, morphology just means the shape of something and its features. So I think we mentioned coastal morphology in the last couple of lessons, which just means the shape of the coastline and its landforms and features. So we can stick another word in front of that and it just means the same thing really. So beach morphology is the shape of the beach with its landforms and features. Yeah, and as we've just mentioned in the previous graphic, also the type and size of sediment as well is a factor in that. Alright, so then we're going to look, today's lesson in a nutshell is all about how waves and tides affect the beach morphology over different time periods. So during summer we tend to get more settled, calmer conditions, especially here in the UK, because the UK does experience quite distinct or pronounced seasons. So in summer, if you think we've got constructive waves with a strong swash and a weak backwash, and they're obviously depositing. Deposition is the dominant process with constructive waves. So what that does eventually is, as you can see, we get a landform or a feature called a berm forming. Alright, and they can get quite steep. If we've had low energy constructive waves surging up the beach all summer, then that process of deposition keeps happening until we get, I mean, this is a really kind of pronounced one, quite steep. Alright, so in summer, berms are built up, the swash is stronger than the backwash, so we get more sediment deposited. Yeah. In winter, however, we tend to get more destructive waves that kind of break from a height. So the backwash is stronger than the swash, and if you were to return to wherever this is in winter, chances are this berm would get eroded pretty quickly. Yeah. So therefore beach profiles change. They change daily, but they also change after storms, and generally speaking they change seasonally as well between summer and winter. Alright, so just to recap, summer beach profiles, deposition is the dominant process. Constructive waves surge up the beach and tend to have a strong swash and a big backwash. So deposition's dominant and we get berms. Winter beach profiles, those berms are very vulnerable to erosion. High energy shocks from storms are going to actually erode these berms and transport the sediment offshore. Alright. Right then, just looking at berms in a little bit more detail. I think I've mentioned this. I mean, what is a berm? There's space for you to draw a sketch, folks. Very important you do a sketch as well as label it on page 5. It's a ridge of sand, shingle and gravel that low energy constructive waves have deposited, result from deposition by summer swell waves. Where are they found in the littoral zone? Well, upper foreshore, where the high tide mark every day. The tide comes in and out twice a day. This is gonna be a signal or a evidence of where the high tide mark is. Yeah. Yeah, they tend to be largest at the end of summer because it's had all summer to actually build up. Alright. Berms mark the high tide mark, however they are vulnerable to erosion during winter storms. So give me a little sketch of that with these labels. Okie dokie. Right, storm beaches at first glance look quite similar to berms, but there's a key difference. First difference is you can see the size of the pebbles or boulders or shingle. It's a lot larger, all right. And as I mentioned previously when I showed you that the different subzones in the littoral cell, then it needs a lot of energy for these to form, all right. So in this photograph it looks really calm and settled, but a storm beach is a signal that quite recently there's been a high tide, there's been a storm, and there's been a lot of energy to actually transport and then deposit larger boulders, if you like. Yeah. So they result from high energy deposition during high tides and severe storms. All right. Where do we find them? We tend to find them on the back shore, which is normally beyond the influence of tides, the normal kind of twice a day when tides ebb and flow. So this could be a spring high tide or a really severe storm surge, a storm that's actually brought these in. What are they made of? Well, larger pebbles, boulders and shingle. Yeah, and because these are much heavier, it needs a lot of marine energy combined with a high tide to actually get them onto the beach. Yeah. Again, do me a sketch of that and then fully label it. It's probably handy if you do berms and storm beaches next to each other so you can kind of spot the difference. Yeah. Typical cock up in exams is students confuse the two. So if you have them next to each other and look at the contrasts, then you're less likely to get confused. Another photograph, obviously this is a storm beach, sorry, not as pronounced as the first one in terms of sediment size, if you like, but you can see, you know, the normal high tide mark would be probably somewhere along this area here, and this kind of ridge just here is on the back shore. Yep, so it's not normally affected by the tide, only at high tides, spring high tides or during storms. Element of beach morphology number 3 is offshore ridges, also known as offshore bores, all right, and we can see one of these just here. Definition of one, right, this where there's space to do so. It's a ridge or mound of sand or gravel deposited beyond the shoreline by currents and waves. So how do they form? Well, they form because of destructive waves. If you imagine we've got destructive waves breaking on the beach, the backwash is stronger than the swash, so they crash, yeah, and then that sediment is eroded and carried offshore, and then it's deposited and it builds up. All right, so these are a landform or feature caused by destructive waves scouring and eroding the shore and the beach, eroding the material offshore where it's deposited. All right. Yep, shingle is deposited offshore. They consist of shingle and gravel, generally speaking. Sand tends to, again, it can get carried further back out to sea, if you like. So when the destructive waves erode it, transport it, and they lose energy, then they deposit it just here. I've got another little graphic here as well in a sec. Let's have a look. It's a bit more of a simplified version, but yeah. Waves break. Here we go. Waves break on the beach from a height, strong backwash, remove material, and then if it hits a small ridge, it deposits it. and we get an offshore bore. Now the thing with offshore bores is, make a little note of this, is you can only generally see them at low tide. Alright, so they're covered at high tide and they're exposed at low tide. Alright. Next one is, well, these kind of work together, alright, because they form, one forms as a result of the other. So we group them together, and they're called ridges and runnels. Alright, and the definition of ridges and runnels: the ridges are parallel hills, and runnels are the depressions or the valleys found at low water mark. So when the tide goes out, you can see these. Obviously, if the tide was in, then they'd be covered at high tide as well. Yeah, you can see the runnels. It's where as the tide's gone out, the water has been trapped in a depression, so it can't drain back out to sea. And why has it been trapped? It's been trapped because of the ridges. Alright, so if I draw the ridges, then there's one just here. Yeah. And there, and there. That's the ridge. The tide's been going back out, and the runnel is the depression in between the ridges. Sometimes you might see kind of a little creek, if you like, that can drain back out to sea, but generally speaking, it's going to be trapped. And if you're kind of wondering, well, what causes the ridges in the first place that traps the water in the runnels, then it's a combination of different types of waves and the tide coming in and out every day. Obviously, nature isn't uniform, it's not static. You know, laws of probability tell you that some waves are going to deposit in one place and the ridge is going to be more pronounced, and not deposit as much in other places. Yeah, it's just odds, really, laws of probability. Yeah, particularly common on shallow and sandy beaches. Again, this is a beach feature where the sediment size is small, so it is sand. Your storm beaches and your offshore bores, the sediment size will be bigger than sand, generally speaking. It'll be shingle, pebbles, or boulders. Alright. Ridges and runnels are beach features where your sediment size is quite fine. And if we have a look at a few other kind of micro features of the beach, here we go. I mean, these are really at a kind of small level, or small scale. Ripple marked sand. Ripple marked sand is kind of like ridges and runnels, but at a really tiny level, at a micro level. So my money is on that if the tide comes in and out twice a day, this ripple marked sand will change. Yep, it will never stay the same. Super vulnerable to erosion and the change as the tide comes in and out. Again, where water's trying to drain back out to sea, when the tide goes in and out, it creates these little grooves or little channels. So you can refer to that as ripple marked sand. Formed as the tide goes out, it creates patterns. Alright, you can see them at low tide, they're going to be covered at high tide, and they're going to change with every tide as well. They're not going to stay constant. Yep, they're going to be eroded, and they're going to change slightly between the tide coming in and out. Next one, which give you a bit of a warning, always causes problems, and students are never confident in explaining these, so we'll see if we can sort it this year. They're called beach cusps, which are again beach feature. And first thing to say is describe them. What do they look like? Well, they are crescent shaped. Yeah, lots of crescent shapes on the beach. Crescent shaped patterns, crescent shaped indentations, call it whatever you will, just remember the word crescent shaped. Beaches, the sediment size for these to form, it's a mixture really of sand and shingle, Quite small particles of sediment. You don't often find boulders and pebbles where these form. If we just expand this little graphic, and I'd like you to do a little sketch of this and label it. Alright, so you want to be drawing this and labeling it. They form tend to form in bays that experience wave refraction. Alright, and when the swash travels towards this is called a horn. Alright, this bit just here, the bit that sticks out is the horn. If you imagine a wave, constructive wave, travelling towards this horn, it's going to split at this point. Alright, so the swash is forced to divide and split either side of the horn. Yeah, and if you then think of the cusp, which is the semicircular bit, if you've got one swash that's split and is heading into the centre from this side of the horn, and one swash that's been split and heading into the centre from the other side of the horn, logic tells you when they meet there's only one way they can go, and that's backwards. So the centre tends to get eroded, yeah, and you can see a look backwash. So the centre of the beach cusp gets eroded, and we get deposition at the horn. Alright, and it creates these semicircular shape patterns. I've got a few more pictures, I think. Let's have a look. Yeah, just here. Always found in low energy bays. Yep, you can see this example just here. We've got a headland, and then we've got the beach cusps found in bays. Again, you can tell this is a bay just by the shape of it, where we've got the beach cusps as well. Yep, and this one, bring to front. Yeah, again, just here. Okie dokie. So a bit of a recap, these are quite tricky. The swash is forced to divide or split at the horn, alright, and we get deposition. The part that's eroded with a stronger backwash is the embayment or the cusp part, where it can only go really back out to sea when these two split swashes converge, if you like. There's only one way it's going to go, and that's back out to sea. Final note, just make a note somewhere on page 5, is that beach profiles and sediment size and the beach features can change over different time scales. Alright, so if we think of the shortest time scale, ridges, runnels, berms can change over a day. Yeah, they can change every time the tide goes in and out, because especially ridges and runnels and ripple mark sand, because the sediment is so fine, the energy from the tide is going to change those features. Yep, you will never find the same beach that is exactly the same after the tide has been in and out. Alright, it is going to change. You're going to get small bits of deposition with each tide. You're going to get other parts of the beach that have eroded. Alright, so coastal environments, generally speaking, are not static. They are dynamic. They're constantly changing. So that can happen twice a day because of the tide. It can also happen over the course of a day if a storm passes. So, for instance, in summer, you might have had constructive waves building up a berm, and then a depression or a cyclone or a hurricane rolls in, and those waves change to destructive waves and erode the berm. Alright, so they change twice a day with the tide, and they can change daily as storms pass and wave type changes. Alright, they can change Beach profiles we've already discussed between summer and winter. Summer, more likely to find berms of sand and smaller sediment sizes. In winter, or after a storm's passed, those berms are likely to have been eroded, and we could have storm beaches form when larger boulders and pebbles have had that higher energy input to actually transport them to the back shore, yep, and deposit them in the back shore. Alright, so yeah, beaches and beach morphology changes with the tides twice a day, and other elements change because of high energy inputs from storms and wave type changes seasonally. Alright, make sure you've got sketches of each one of these fully labelled. Any questions that you've got ready for me, if you don't understand anything, have them ready for lesson. Alright, ciao.